Good evening, everyone, and welcome to this webinar series. Thank you for joining in. Let me quickly introduce myself. I'm Shantanu Choudhary. I lead the sensing and IoT part of the business for Honeywell, and I I work on building connected solutions using sensors for Honeywell. So today we are going to talk about connected sensors. Uh, it's an interesting topic, and I'm sure you will have a lot of questions in your mind. One sincere request is note your questions as we go through the slides, and we'll have time for question and answer towards the end of the session. And I'll try and answer to the best of my abilities. Let's get started. Here's a quick overview of the agenda for the day. We're going to look at how's the IoT market, quickly scan through the IoT stack, and then I'll jump into the topic, what are the connected sensors, what role do they play in today's IoT era, how do we get them connected, and what is required to get the data from these connected sensors to the cloud, what are the challenges, if someone has to get started, how do we get started? So that's a broad agenda for today. Uh, So I'm sure all of you have seen this picture some other time during the course of your learning. So what this picture depicts is it depicts a basic sensing ability of human beings. So here, if you see many people are trying to understand by their feelings what this creature is, and everybody is deriving a different meaning out of it. So it all boils down to sensing elements, and in this case, the senses are our nose, ears, hands, because the eyes are tied. So sensors do play a very critical role in day-to-day life for a human being, and same is true with industry. Same is true with technology. Sensors do play a critical role uh, in technology, and basically it helps us understand what's happening around us. So whenever we talk about Internet of Things, sensors helps convey meanings of these things to us. So these things are nothing but every object around us. So we'll get into more details of that, but to give you a quick perspective, sensors really form the foundation of Internet of Things. uh, I'll quickly give you a brief overview on what's IoT scope for today's world. It's it started as kind of a third technology trend. If you just scan through the last era of about 50 to 70 years, we had first trend of mechanization, second trend of uh, automation, a third trend of internet, and sorry, this is the fourth trend which is triggered in the technology area. And this trend is basically capturing information between different objects which are around us. And when these objects start talking to each other, this is called as Internet of Things, and these objects are called as things. You can consider a bottle of water as an object, you can consider a phone as an object, you can consider your home as an object, you can consider yourself as an object, or the chair that you're sitting as an object. So any object is treated as a thing, and the communication between multiple things is called as Internet of Things. Uh, Various surveys have gone in place talking about what is the potential of this market, what's going to happen with Internet of Things, and it's expected to have about 11.1 trillion impact on the economy by 2025, with humongous amount of devices connected to each other and to internet. What it means is these humongous amount of devices are sensing something within themselves and sending that information across internet. Uh, if I have to take some of these examples, today we talk about uh, medical devices. We talk about wearable medical devices. It starts from a Fitbit. So most of us wear some kind of fitness band which tries and tracks information about our health statistics when you're running, walking, how many steps you have walked, what is the heart rate, and all of that. And that's getting communicated to your cloud, to mobile phone, to an app, and all of that is helping us understand our health activity and help us improve the healthcare, help us improve our fitness there. Same is true when someone visits a hospital. There are many bands and many things that are applied to a patient to just monitor a patient to understand health statistic of the patient. So sensors are used in that application. Sensors are used in supply chain. You imagine you ordered something from Flipkart or an Amazon, and you track that order. So how do you track that order? There's something which is tracking that order. There's a GPS sensor which is used to track that order. Now, similar thing applies to when you order food from, let's say, food basket or big basket or Goofers, anybody. So similar thing applies in supply chain. Now, sensors also, or IoT also plays a critical role in industrial scenario. So here, industry is spread across multiple verticals. You talk about factories, where the IoT is helping the factories be smarter, be more automotive, reduce errors, improve productivity, improve yield from the factories. Imagine a factory which is uh, manufacturing Coke, and you have sensors which try and understand the temperature of the Coke mix, the temperature of the water that flows in, the amount of pressure that is applied when bottling is done. So that really helps improve the preciseness of the whole process and improve the productivity of this manufacturing process. It also helps reduce cost in the manufacturing. You can control your electricity, you can control your HVACs, all of that through connected offerings. So it really helps improve the productivity and reduce the cost of operations there. We can talk about workers in the factory. There are multiple equipments that are enabling a worker to be more safe than what it used to be earlier. Uh, Very common application of connected products or IoT products is in homes. We see a lot of new products coming to our homes these days, and all of them are really smart and connected. You buy a TV, which is a smart TV, which can be connected to internet, and it has so many sensors inbuilt in. It can detect a light and adjust brightness accordingly. You buy a thermostat, or you buy AC, which has a thermostat inbuilt. It can control the temperature according to the temperature inside the room. The ACs are also become smarter by self-cleaning themselves whenever the filter goes bad. So a lot of home equipment that we buy, a water purifier for that matter, a lot of home equipment that we buy today, they do come with a lot of sensors inbuilt and a lot of connectivity built in and a lot of smartness built into it. So it's all around us. We don't have to search specifically what is IoT, what is connected sensors. It's all around us. I'm just going to extend this into some more examples. All of us walk with so many sensors in our pockets every day. Imagine a smartphone. You have at least 15 to 20 sensors in a smartphone. We hold the smartphone near our ears while talking. There is a proximity sensor which uh, disables the mic being muted there. There's accelerometer which tells us if the phone is straight, flat, or in which condition. We today use fingerprint sensors to unlock the phone. We use the GPS in the phone to really understand the location for ourselves or as well as for the phone itself. The ambient light sensor in the phone really reduces or increases darkness and tells us what is the optimal way of looking at a screen. So many sensors inbuilt, and this is going to grow as we make progress. If I have to really compare the phones that were in around 2010s or early 2010s, they possibly had two or three sensors which used to tell us, okay, there's something vibrating, there's something happening there. But today there are enormous amount of sensing capabilities even in a smartphone. And mind you, all of these are connected. So all of this information coming from all these sensors is being transmitted. So you are being monitored, obviously. You also use various apps which use these sensors and collect information for yourself. So we all walk with sensors and connected sensors in our pocket in our day-to-day life. So that's to be put in simple way. That's the connected sensor actually. Let's move on to understand how these connected sensors are really made and what is their role in an IoT stack. This is a typical IoT stack defined by Honeywell. So if you look through this, there are about 6 layers of this IoT stack. The lowest layer is sensor. Uh, this is a very domain-specific sensor. So what I mean by domain-specific here is, if you are using if you are in industrial segment, you will use industrial sensors. For example, a pressure sensor, which is used to monitor pressure of a gas pipeline. If you are using a consumer good, You will use consumer grade sensors for example, the sensors we just talked about in our cell phones. If you're using sensors for home, we'll use light sensors, we'll use temperature sensors, which are more easily accessible. So these are very, very domain specific sensor. So each application will have a different sensor. And we'll talk about that in a little bit on what are the specific applications of these sensors. But what happens is these sensors collect information of changes happening around us, and they convey that information to the layers above them. So basically, the sensors collect the data or senses the information of change, then processes this data within themselves and sends the data over either a wired protocol or a wireless protocol to a device called as edge device. Now, this edge device is nothing but a accumulation of multiple sensors together. It has a little bit more processing power so that it can do some processing. Consider your thermostat as an edge device. Consider a small phone as an edge device, a smartphone as an edge device. So these are uh, aggregation of sensors which are together and they convey the information over cloud. Gateways, these edge devices can directly talk to cloud or they talk to cloud through gateways. Now, these gateways are primarily used where we need high processing power, where you need basically multiple devices coming and talking. These are used in industrial segments where you have protocols which are wired as well as wireless. Some of the industrial devices work on Profibus, Modbus, uh, these kind of protocols, or some of the proprietary protocols. So these gateways get information from these wired devices as well as some of the wireless devices, and then talk to the sensors. So gateways then sends data to cloud over mostly the wireless protocols like 2G or 3G or LoRa, or in case of factories it would be over wired Ethernet, where the data is really digested, stored in a data lake, and then there are insights being driven out of it. Insights are nothing but meaningful information which helps take decisions. For example, insight from my heart rate monitor in my phone is, okay, your heart rate is going a little bit high, so you need to take some control actions, or you have not done enough of walking for the day, so please walk. So this is the insight that I get. Or I have a regular habit of walking, let's say for 10,000 steps a day, but today I've just skipped all of that. So the insight can tell me, okay, you've skipped today's walk, you might want to cover it up by some other way. And consumption is pretty simply showing how do we use that information. So this is a simple layer stack up. What differentiates these IoT applications is the insights and the consumption, the way it's consumed. Uh, so you can do it in multiple ways, and that's what differentiates a particular IoT solution from one to other. We are now going to look at what really are these connected sensors. So connected sensors basically are sensors which demonstrate some of the features or some of the attributes. For example, a sensor tag, a sensor tag which is used for which is used for logistic purpose. For example, if you are sending some goods which are costly, which are fragile, I'll take an example of a polio vaccine. I'm Recently we have conducted a polio day where doses were given to millions of kids across country. Now, if you have to monitor these polio vaccines uh, for their for their health, so that they don't get spoiled during the process of transportation, you might want to have some sensors which are stick to these boxes which carry these polio vaccines. Now, these sensors, which are really monitoring the temperature, humidity inside these boxes, cannot be tracked back. So these needs to be disposable. So what it means by disposable, it has to be a pretty low cost sensor which can be disposed of. So a connected sensor should be a pretty low cost, disposable kind of an sensor which really can be disposed of if the application calls for it. Similar sensors are used in healthcare industry, which wherein these sensors are pasted on patients, where these are used to monitor various health parameters of a patient, or they are stuck on the uniform that a patient is given to monitor various parameters. So it has to be low cost and potentially possibly disposable if the application demands. Uh, Second trend that you see is wearable. We see a lot of wearable devices. It's not only Fitbit, but diverse watches, the safety work clothing, the PPEs. I'm sure you would have heard of Google Glasses, which is not necessarily a PPE, but can essentially be used as PPE. PPE is personal protective equipment, just for the information of those who do not know it. But wearable is really a trend wherein most of these sensors are being weared, either in the form of a belt or in the form of a clothing or in form of a suit or in form of shoes. So let me give you a few examples here. When we talked about Fitbits, but these Fitbits also help understand heartbeats. These also help understand your workout patterns. These also help understand your workout rhythm and can give you insights in terms of if you're missing some things, if you're burning less calories, if you're burning more calories, to monitor your workout regime actually. The diverse watches, for another example, these are the watches which are used in deep sea. Again, have a lot of sensors. A critical sensor that goes into a diverse watch is the pressure sensor to understand what kind of pressure that the diver is going to. Because beyond the pressure, there are health hazards for drivers. Safety workers, there are wearables for safety workers who really wear those uniforms and go either for firefighting or work at heights. And these wearables have various sensors inbuilt to it. For example, there are temperature and humidity sensors inbuilt into a uniform of a firefighter to know if there are temperature changes in a firefighter's body because of his existence within the vicinity of heat, and if that's impacting his health. Similarly, if a worker is working at height, his various gauges that he uses would have some sensor which tells others or the supervisor at what height the worker is working. Is he wearing required safety measures or PPEs or not? So all that information is conveyed to required people and the supervisors and the managers to know the safe operation of that worker. A similar thing is with PPEs. You use various shoes, different types of shoes for different kinds of applications. For example, you use a different kind of shoes with rubber soles when you are dealing with chemicals, and that needs to have different kind of sensors inbuilt into the shoes, telling you the chemical hazardous as well as the pressure that is applied onto your feet during that. Also, some of those PPEs can tell you how much load or weight that the person is putting up, which might be against a regulatory requirement, which is causing the health hazard to an individual. So this has what this means is what this implies, this connected sensor has to be a small and miniaturized, which could go into variables, which could get fit into this PPE, which could be really applied onto this clothing. So it has to be really small in size and miniaturized uh, to be able to fit onto these devices. Another trend is most of these devices are going to be mobile. What that means is these are going to be moving around. So we just talked about the polio vaccine. Imagine this polio vaccine is not going to be stationary. These boxes are going to move around different places. So they need to be battery powered, or they need to be low powered, as much as low powered as they can. The vehicle tracking devices are very commonly used these days, and these devices are pasted inside the vehicles or inside the boxes in the vehicles. So they need to be also battery powered. So a lot of these devices which are used in mobile applications, wherein the object is moving, needs to be battery powered because they cannot be powered through a regular power lines. And what that implies is these sensors have to be very, very, very low power. These have to be ultra low power sensors, which consume low power when they operate. And obviously, as we talked through, these sensors generate humongous amount of data. And what that data does to us is that data gives us ability to improve the productivity in a plant, optimize the performance of a plant, for example, optimize performance of a machine, uh, improve your home automation. For example, you can ask Amazon Echo or Alexa to control the temperature of your home, or set to your mood before you enter into the home, or trigger a music before you enter into the home. So these sensors will help generate a lot of data and also help us take a lot of actions. What that implies is these have to have some local intelligence built in so that they can take some actions and draw some insights. And they also need to be wirelessly connected. So connectivity becomes a big part of that. So connected sensors do come with these attributes, typically a low cost, small and miniaturized, battery powered or ultra low powered, and with connectivity either wireless or wired in some cases, with intelligence built into it. So small footprint, low cost, battery powered or ultra low power, and with connectivity options. So this is typically what a connected sensor would look like. And where do we find them? These are all around us. We are surrounded by these things. All these different sensors that we see at the bottom of it are used in everywhere around us. I have listed a few examples here of the applications that uses connected sensors, uh, but there could be many more. For example, you are approaching a mall and you really want to understand if the parking is available inside a mall or not available. Instead of you going there circling around in the mall, this connected sensors and IoT application can really help us understand and reduce wastage of our time in finding the parking. Uh, a connected building application will have connected sensors in terms of fire detectors, in terms of gas detectors, in terms of your safety systems, in terms of your intrusion detection systems, in terms of your energy meters. So all of this will be connected and will help you manage your safety of that building, help you manage uh, safety not only from intrusion but also from your gas hazards, also from your fire hazards. And obviously, the cameras will help you. Cameras and intrusion detection systems will help you manage your security of individuals barging or unauthorized access. So very useful in case of connected building. Connected vehicles, huge applications in connected vehicles. You would find most of these new age vehicles come with tremendous amount of sensing capabilities built in. You would know what kind of an seat arrangements that you have, what kind of mood you want in the cabin and the lights. The wipers turn on automatically when they see rains coming up. The lights turn on automatically when they see dimness in the light outside the vehicle. The the seat belt indication is given to you if if you're not wearing a seat belt. So a lot of these sensors do get embedded into connected vehicle. And these days, when we talk about autonomous vehicle, lidar is another sensor which is prominently talked about there. What this does is this really looks at things in the proximity of a vehicle, and alerts the vehicle system to take respective action to avoid the collision there. Let's talk quickly about the industrial applications of connected sensors. I can give you a couple of examples here. Machine health monitoring is one of the prime application. Imagine you are using a motor in an industry, and that motor normally is working in a normal working condition would generate certain kind of noise, would generate certain kind of vibration, would have certain kind of temperature around it. Now, you you would not know the health of that motor unless you find out there's a fault or the motor stops working, unless it's making humongous or tremendous noise, which is creating trouble to people working around. But the moment you have a connected solution which is used on top of that, not only you can monitor the vibration parameters, you can monitor the noise parameters, you can monitor the temperature around it, and these things will help you predict the failures well ahead in time. For example, vibration on a motor is the first kind of analysis trigger point that can tell you in advance that a motor is about to fail. Similarly, the noise and the temperature can give you more indicators. That's a very simple example of a connected sensor helping you prevent a failure or take a preventive action of maintenance before something fails there. Another thing on a connected factories, you've seen a lot of factories use a lot of liquids or chemicals in their plants. Now, we normally people tend to order these chemicals or oils or liquids before they get consumed. Now, the moment you have a connected application in that, you're monitoring levels of these tanks, levels of these chemicals, and you know how to and when to order the inventory just in time. You can very well connect this to your vendor inventory ordering system or your basically ordering system to order that automatically. So it gets ordered automatically. You have the order coming in before you consume your stock. So various applications helps improve the productivity. Another application in rural India, you can say, is connected farms, I would say. Uh, the sensors today can help you understand the soil quality in a farm, the moisture levels of a soil, the various chemical levels in a soil, the pesticides level in the soil, and this information can be available to you on your mobile. You imagine you are taking a crop and your moisture comes down, and you can trigger irrigation system really to start watering the plants. You also don't want it to be overwatered so that the roots get spoiled. So the sensor immediately triggers a notification back and says the watering is the required watering levels are achieved or required moisture levels are achieved, and you can stop watering. And it can also automatically control the irrigation system. So pretty simple application in connected farms. Same can be extended to your greenhouses or your precision farming equipments, where you're really sowing some high quality fruits or vegetables or flowers. I can take another example of energy wind farm where the windmills are connected to each other through sensor connections. So the first windmill which is seeing wind coming in the direction can also talk to other windmills and have them change their pitch or their movement direction of the blades based on the wind flow. They can also talk to each other based on the amount of energy that they generate and decide which one can go on and which one can go off. So there are applications which helps improve the production of a wind farm based on connected sensors. I've just given few examples of connected sensors which normally are used in various instances or applications. Uh, uh, for example, the humidity, pressure, tilt, speed, gyro, light, barometric pressure. These are very commonly used sensors, apart from the ones like proximities, LVDTs, which are very specific sensors, is used in very specific applications. But you would find these sensors which are commonly available, which are commonly used in connected applications. Uh, these sensors, as I talked through, uh, are the ones in the age of data. These are the ones which generates data for analysis. Uh, we call today in today's scenario, we call data is a currency. Data is a new currency, and these sensors are the ones which generate this currency for us. So these are these really play a critical role in day-to-day life. Uh, and that's where it becomes critical to have these sensors connected, have this sensor talk to different layers in an IoT stack and send information. I've taken an example of a plant which came out of one of the study report uh, from analytics.com. This is a plant which manufactures consumer goods. For example, the the air purifiers, or for example, the fans or the ACs. And this particular factory has more than 150 to 1,000 sensors which collects data every second. Now imagine you have these many sensors in your factory, and these sensors have to be sending information across all the time, real time. And these sensors are used in various applications, right from you're managing the electricity of your factory, managing your equipments, managing your people, uh, managing safety of a factory, safety of a worker inside the factory. The amount of data that it generates is humongous. You have 9 million samples generated per minute, and which really turns to 4 trillion samples a year. Now, this data is really critical for analyzing the information and taking right decisions. That's why sensors play a very critical role in conveying that right amount of information and right amount of data uh, to upper layers. That's why I'm calling them as data generators in the world of data. This data is normally then passed to data lake, and that's where it gets analyzed in the cloud. We'll move to the connectivity part now. So I'm going to focus on wireless protocols only today. There are wired means of connecting a sensor to IoT system, and these are very commonly available. These are being done typically in process industry for quite some time through various industrial protocols like Profibus, Modbus, Profinet, uh, some specific industry-specific protocols like HART. So these are done in the industry for quite some time. I've covered basically protocols which are wireless, and to just to give you a sense of how you choose a particular wireless protocol for a given application. So if you see the picture here, it clearly demarcates different protocols. And let me tell you, this is not an entire coverage of all wireless protocols or radio formats that are available today. There are more than 60 to 70 radio formats in the era of IoT or machine-to-machine communication, and I've not covered all of them. I've just covered few which are majorly used. And I'll talk through each of them. A broad selection criteria for these wireless protocols is based on the application range. So what I mean by application range? So if if application is used in a very close proximity, for example, a barcode scanner or a barcode reader or a NFC reader, if you're using it for scanning kind of an application, you would possibly want to use a very close proximity protocol like NFC or RFID. Uh, but if application is used to communicate information across cities or across countries, then usage of a cellular technology uh, or this kind of 2G or 3G technology or satellite communication is preferred, because that defines the coverage of the information that you would want to send across. All these protocols are bound by two major aspects. One is the power that they consume, and second one is the range. And these are two contradicting requirements that are on these protocols. So as I said, the closest range would naturally go for something like NFC, where you can really tap to the device, or you can really scan the device. These are very popular in wireless payments. So a lot of the credit cards are today built into these kind of NFC chips, which can then talk to the credit card readers, and these can automatically detect the credit card credentials and can make the payment. So these are very popular these days. Next comes the kind of immediate vicinity, I would say, within your home or within a room where you have line of sight distance available of few meters. That's when you should be using Bluetooth or a Zigbee protocol. Again, there is a difference between Bluetooth and a Zigbee protocol, the way they are used. Um, with Bluetooth 5.0, it does come with a lot of different capabilities, and Zigbee has its own advantages. But these are the two protocols you can naturally use in the applications where you are really looking at scanning or talking to devices which are in the range of few meters. I'll give you a couple of examples here. Uh, One of the example is if you are really sending some boxes inside a truck, and these boxes can talk to the central gateway through the Zigbee or BLE protocol. Uh, if you have a few devices in your home, they can talk to each other over Zigbee or a BLE protocol. For example, you have a thermostat, you have a gas detector, you have uh, light switch, or you have a automated lighting system, dimming light system, or you have automated fan controls or HVAC control. They can talk to each other using Bluetooth or Zigbee, or even a proprietary protocol. But these are the protocols that can be used. Uh, Next one is pretty much your Wi-Fi kind of thing, which you can use it in your home application as well as close local area applications. And again, these applications can range from some of the mobile applications to your home applications to a connected building kind of an application where the Wi-Fi is available within a building, and you can have all these devices talking to each other. But again, as I mentioned earlier, all these protocols do have implications on the power that the device consumes. So a choice of protocol should be a trade-off between what power options that you have available for yourself, what area that you would want to cover for communication, And based on these two primary factors, you should be choosing your protocol for connected sensor applications. Uh, the next one is Zigbee NAN or Wi-SUN. Again, these are used kind of an inter-building kind of an application. You don't have long range, but you do have some line of sight. Uh, this is not so very popular because once you cross Wi-Fi, you normally end up using cellular or LoRa kind of a communication mechanism because that gives you a very broad coverage. So not a very popular protocol, Zigbee NAN or Wi-SUN, but is used in some cases. The cellular LoRa or Sigfox. Sigfox is primarily developed for metering applications and is very proprietary, used in metering kind of applications. Could be water meter, could be electricity meters. Cellular communication again can be used across different applications. For example, you have a smart IoT system in your farm. You can have a cellular connection sending data across uh, from that farm to the cloud and through cloud to your cell phone on your app. Real-time data can flow in through 2G or 3G, and that can give access to you for the data anywhere in the world. Similarly, you can track your bike or your vehicle using that cellular connection for safety or for anti-theft kind of an operation uh, from anywhere. So cellular is primarily used there. LoRa again is used where you have line of sight as well as a long range communication is required for IoT applications where low bandwidth is required again. So LoRa is used again, a very good protocol, uses the existing infrastructure of sorry, it needs a new infrastructure to be created. So a little bit infrastructure intensive, but can give uh, good communication strength in long range. So as I mentioned earlier, these protocols are essentially to be used based on the applications and based on distance as well as power. So power and distance of communication plays crucial role in conveying or in selection of these protocols. We'll look at how the data is conveyed from these sensors uh, to various cloud levels and what kind of services are used. I've listed very few services here. These are uh, normally these are similar across, but these are very few sensor specific services. These are not a list of entire services that are used across cloud platform, but I've really focused on sensor specific services. So as you see, sensors at the bottom, which can act as an end device, and you have to really have a cloud registering that device either through a edge controller or directly, if it's directly talking to cloud through a 2G or 3G communication. If it's talking to a gateway, then you can register the device through a gateway, uh, which essentially helps you know that information is coming from a particular device through identification updates of the device. So it's critical to have a device identification for each connected sensor when you are sending that information about that particular sensor. The another service that is normally used is for firmware upgrades. So as we talk through, these have to be smart sensors. These have to be communicating. So they obviously have firmware element inbuilt to it, and those firmwares would need some timely upgrades for bug fixes, for enhanced features. So you would have a firmware over the air upgrade facility using some of these services. Event streams. So whatever event happen, so some of these sensors can have inbuilt intelligence to store and send event information. For example, the sensor failed, or the information from where the sensor is getting the data is failed, and the sensor can note its reading before that event happens and after some readings after the event has happened, and can communicate that information across event streams. It can also send alarms over alarm services based on the thresholds that are set, and obviously it can be controlled remotely for commands. So these are typical services that are used for sensors only, sensors, and also to certain extent some edge devices. But let me tell you how the data flow happens from sensors uh, to the cloud and various devices. We talked a little bit about sensors sending data to an edge controller, which aggregates the data through some of these protocols. We talked through Bluetooth, we talked through Zigbee. RF6 is a proprietary protocol for Honeywell. So it uses a proprietary information to communicate between devices within a home for gas detectors. So these sensors uses any of these protocol to send this information to edge controller. This edge controller, as I mentioned, can have wired or wireless connections. It can take information from some of these wireless devices and then also talk to some of the wired devices over Profinet or some of the other protocols. These edge devices can directly talk to cloud or can talk to cloud through gateways. Now, these gateways also can have multiple other edge devices or other sensors connected to it, and can have user interfaces, and users can look at the data. Uh, these gateways can talk to edge devices again over wired protocol or wireless protocols. Again, the selection of protocol depends upon the range as well as the power requirements of that. The gateways are normally connected to cloud through a wired mechanism by routers in case of factories, and through wireless in case of remote applications or in case of mobile applications. And that's where it sends information coming from sensors to cloud. Uh, the gateway also sends information to your applications or to your basically the layer where the visualization comes into picture, where we see the data, see the information coming from sensors using mobile app or even PC apps or through web apps. So this is where the gateway can talk to web apps directly through a wireless communication. So this is a flow of data, information exchange that happens from a sensor, in case of a connected sensor, to the cloud. We are going to look at some of the challenges in terms of connecting these sensors. Some of them we did talk through during the course of this discussion. I'll start with power constraints. As we talk through, these sensors need to be ultra low power because they would be operating at different places, they would be placed in different places. You may not necessarily have power connections always available. So they have to operate at a very, very low power, and they have to consume very low power for themselves as well as for communications. The communications consume a lot of power, so they cannot be really consuming a lot of power. So power constraints and battery operations forms a very, very deciding factors in terms of designing a connector sensor. Second comes the computing power. As we talk through, these are remotely placed, so obviously they cannot have humongous power-hungry processors uh, built in these sensors electronics, which can take power, but they need to have some kind of a processing of information to create alarms, to generate events, to store information about uh, unregular performance or behavior of a sensor. So they need to have some kind of a processing power, but will have very limited amount of processing power. So you have to be cognizant of the fact that what you want to run at sensors and what you want to run at cloud or at the edge level. So limited computing power becomes another challenge when you are connecting the sensors. Same is true with the memory. Uh, as we store information in the sensors, and I'm really talking about all of this within the sensors. Imagine a temperature sensor or a sensor combination sitting on a remote machine and having all these things within it. So you need to be really cautious of uh, all the electronics, all the power it consumes. So you would have very limited memory to store the information available. So you have to be selective about what do you store, what do you really not store, and what do you let it go, and how much do you store, how long do you store. Connectivity and cost of communication. These are interrelated points. Limited connectivity for the reason again related to the power supply constraints because these are normally battery operated devices. They are power cautious devices. So you would not want to have continuous information being sent across to save power. So you would want to have these sensors go in sleep mode, then based on event or based on frequency, collect the data and then send across, and then again go back to sleep mode. So it's not a always connected thing. So you will have limited connectivity with the sensors, and also depends upon what kind of architecture you have. If you have gateways, if you have edge devices which are in near vicinity, then you will have a regular connectivity. If you're going to send the information through, let's say, a BLE, and through the BLE communication is to the mobile phone, where you go near to the sensor and collect the data and then go away, then also you'll have limited connectivity. As I said, the connectivity and cost of communication goes hand in hand. So if you want really high connectivity, the cost of communication goes up. So based on the amount of data that is sent, the communication cost varies. Last one is the real-time response. You would obviously want these sensors to be giving you real-time response. You would not want a delayed response. You would not want to know if your food which you have ordered is stale after the food is delivered. You would want to know before it's delivered so that you can talk to the delivery boy. Uh, so you have to be really cautious when you choose what kind of real-time responses you would want, where you can afford to have delayed response or where you can afford to have slow response. For example, some of the parameters in the weather don't change frequently. So in that case, you can afford to have slow response uh, from a sensor. So you can decide the frequency of response based on the application here actually. So these are major challenges when you design a connected sensors. So these are kind of trade-offs that you end up with when you define the sensor for yourself. We'll quickly talk about if at all you have to define or get started with connected sensors, how do you do it? Honeywell has sensor development kits which are available on the Honeywell website. There are drivers available for these sensors. These are easily usable with the uh, available Arduinos or Raspberry Pis. Various protocols are supported and various sensors are supported. I recommend all of you guys to go to sensing.honeywell.com and look at these development kits available for you. You can order them, and you can also get a software which you can use it for knowing the values coming out of sensors. So I suggest use these development kits. There are similar kits available from different suppliers, which you can take use of, which also comes with the drivers. So use these development kits to get started making your connected sensor. I'm going to quickly cover a few of the applications of these sensors. A lot of it I've talked about it. I'll quickly cover a couple of things which are specific. I'm going to cover a connected worker and a freight application here. Uh, so connected worker application really is about putting sensors onto worker to know status of health of the worker. Imagine a worker who is gone to know the status of a pipeline in a remote area, and he's a lone worker. You would definitely want to know the status of the worker. If it's a hazardous gas, you would want to know if he has come in contact with hazardous gas, if he's really good by his health, if he's conscious, if he's non-conscious. This information needs to be passed to a supervisor, and that happens through a connected worker solution of Honeywell. Also, the kind of devices that he has to carry needs to be regulated, needs to be calibrated always. So this device status also gets passed on to the supervisor, to the plant manager, who is controlling and who is watching these workers always. Uh, this gets informed through connected sensor application. If a worker is working at a height, obviously the height information goes to the supervisor, but also the PPEs that the worker is wearing, that information also goes to worker. So to the supervisor, so that supervisor knows that the worker is safe or if he needs to take some actions. Uh, so there are various advantages of this connected worker solution, and this really makes sure that the workers are safe in a given work environment, which is a major cause of casualties in a work environment, in an industrial work environment. I'm going to cover connected freight application. Rest of the applications you can really log into Honeywell website to know more. Connected freight is a recently released application of connected sensors for Honeywell. What happens is if you have a high value shipment, for example, you are sending medicines, you are sending some of the pharmaceutical chemicals, or you are sending some valuable goods, you would really want to know status of those valuable goods throughout the journey. This solution typically talks about monitoring even a single box. For example, you are sending some of the very costly medicines in a single box of, uh, of let's say 10 inch by 10 inch, and you would still want to monitor that. You can paste a sensor tag which can gives you information about the pressure, temperature, humidity of that box. Also, it can tell you if the box had gone through some shocks and tilted it, during the journey, either through road or through air or through sea, and this information is available to you on real time. You also get to know if something is happening to that box, if somebody is taking out something from the box because of the light sensor that is available on the box. So it gives you insights about the shipment at a box level, and that's the critical part of it, because some shipments you would really want to monitor at a box level. Uh, so this really plays a critical role in monitoring the shipment. It helps avoid spoilage of these perishable goods. It helps avoid theft, and it also helps you take action, preventive actions in really quick time. So if you know that some theft actions are happening, you can really talk to the driver, talk to the people around them, and convey that information. So you can really take immediate actions there. So there's a lot more to this particular application, but I would recommend you to go onto the website and look at what are the features of this application if you are interested in more information about it. I'm going to take a pause here because we are about 10 minutes left to the session, and take some questions here. One of the question is, what is the trend going to be, gateway or without gateway architecture of connected sensors? Uh, there is no generic trend, my friend. Uh, it completely depends upon the application. You would really have to look at the application and then decide if you really want to have a gateway or not want to have a gateway. Today, as I talked through, the sensors can themselves send data to cloud through various protocols. And if you feel that your application can afford to have those protocols built in, you very well go ahead and build those communication protocols, which can send data to cloud directly. So it's basically depends upon the application whether you want to use a gateway or not want to use a gateway. Gateway primarily act as an aggregator. I'm going to take the next question. Uh, how light sensors will work if consignment is in a remote area? Very interesting question. I hope it is related to the freight application. These sensors are put on the box, and if someone opens up the box, you would know the light information, because normally the box would be closed. So you would know the light is passing in the box. So that's how the light would work. And even if it's in a within a container for that matter, it will work that way. What is Honeywell Sentience located in this framework? Where is Honeywell Sentience located in this framework? Okay. Honeywell Sentience is a framework which is used to get the information from sensors to cloud and then do analytics in the cloud. So it's basically across uh, across different levels. I would say right from your edge level to your cloud level. We do have sensor data models available for sentence compatibly in Honeywell. So it also has a sensor element to it, but sensors are very domain specific. So that's not included, but the sentence stack is available right across above layers. Which protocol for vehicle tracking sensors, especially in logistic industry? Uh, so if it depends upon what you want to track. If you're tracking a vehicle, you can very well use a GPRS or 2G, 3G connectivity, because it's a mobile application and you may not necessarily have line of sight information always. So 2G or 3G or 4G these days, or LTE is preferred. In an industrial scenario, isn't gateway mandated to handle security aspects? Yes, my friend, it is required to required to handle security aspects, but we do have securities inbuilt into even at a sensor level now. But industrial scenario would normally have a gateway, because you would not have a single sensor talking to cloud through one communication protocol. So you would have aggregation of sensors, and that way you would always have gateways. So gateways would take care of a lot of security requirements. Same, there are security requirements for the sensors as well, because sensors also are prone to security threats, be it BLE based communication or be it firmware or the air upgrades. You would want the sensor to have right firmware to behave appropriately and give you right data. How to make sure that data sent by my sensor is only received by my cloud app? I think that's where there are services for device registration and device authentication, and those services will help make sure that your app is seeing the devices which are meant to be seen, or specific devices that are your devices and not somebody else's devices. And it also goes on to how do you manage the devices, how do you manage the cloud aspect of it. You should have most of your devices uh, through talking to your cloud through your device authentication registration services. That way, it will be a closed interaction with the devices. Obviously, mobility sensors have to be independent power sources. So, is there any recent proven energy harvesting mechanism in low cost uh, and also compatible in size? A pretty interesting question. There are some RF energy harvesting technologies uh, which are available. Uh, Cost-wise, it's it's again the number of sensor that you integrate decides your solution cost, and you always have to look at solution cost in that case and not really a per sensor cost there. So if you have decent size of sensors or decent number of sensors that you would want to integrate, there are energy harvesting mechanisms, but reliability of that depends upon the environment that these are placed in. I'm going to take a couple of last questions here. I think that's pretty much. We have covered most of the sensors, most of the questions. Thank you for joining this session. I hope this was informative. Uh, you can reach out to us through Honeywell websites for any further information, uh, or you can reach out to us through the contact information available on the webinar website. Thank you and have a wonderful evening.